Hi, welcome back. In this lesson, we are going to learn how to use independent t-test in SPSS. This independent t-test is a parametric test, okay, and it is a two-sample t-test. Why it is called two-sample t-test? Because we are going to use two different group samples, okay. So these samples could be the salary of two group of employees, let us say male and female, or executive and non-executive, like that. Okay. It could be the sales amount of two stores, everyday sales amount of two stores, and here what we are going to test, that whether there is a significant difference in mean exist between the two group of employees as far as salary is concerned or the sales is concerned in case of stores. Okay. So this is called independent t-test because the samples are independent. That means there is no dependence relationship. What happens in case of a paired t-test? Samples are paired, means dependence relationship is there. Suppose there is a treatment, we organize one training program and there are some 20 people participated in the training program. Okay. And whether there is a significant difference in the mean performance before the training program and after the training program, we are going to test in case of paired test. Okay. Okay. Another that assumption that we should check here before running this independent t-test. Okay. So the data has to be normally distributed. The data that we collect the metric data, this needs metric data or numeric data. This has to be normally distributed and the data has to be homogeneous. If the data is not normal and homogeneous, it has a substitute test that is called Mann-Whitney test we can use. Okay. So for the present, to understand this, we are going to use a case study. Okay. So this is a case study that we are going to use. We have salary of 40 employees, 20 male and 20 female. This is the salary. Okay, let us see the variables. So this is the gender. Gender is male, and we have coded it as 1. We can say coded it as 1 and 2 female. Okay. So this is nominal because it is a text based variable. So this is salary, this is a metric variable. Okay. So this is a scale variable we have taken. So first thing that we must check whether the data is normal or and homogeneous or not. So we have to go for this. There are multiple ways that we can check this homogeneity and this, and we will see analyze, descriptive, then explore. Okay. Then this is the salary, we have to take it to dependent list. This is the gender, we have to take it to factor list. Okay. Then we will go for plot. So there are multiple ways we can check also histogram for this. However, we will go for normality, plot with test, and there is also this. So this normality test is done through KS test, and this is on transform. This is Levin test actually. Okay. So this will check whether there is a homogeneity of variance exist in the data or not. Okay. So then we can continue. Then we okay. So now we will get the output. This is the male salary, female salary. This is the number of sample 20 and 20, and there is no missing data. This is the mean 49,900, and this is the mean of female salary 39,400. Let us remember, it is natural that the mean salary there will be a natural difference. Okay, there is high probability that there will be a difference. But what we are checking here, whether there is a significant difference mean exist in the two group samples or not. Okay. So this is one way. If the skewness and kurtosis values we are getting, it is between +1 and -1. That means data is normal. Okay, that is one way we can check. That means this data is normal. So here female, we can see this is also between +1 and -1. This is the data is normal. Okay. So there is one normality test of normality we can check. Okay. So this is the test of normality or KS test. So how can you know that whether the data is normal or not? This is the p value. This is the p value. Okay. P value, significant value. The significant value or the p value has to be non-significant. Non-significant means it has to be greater than 0.05. If the p value or the significant value is greater than 0.05, that means we conclude the data is normal. So here we can find male significant value is 0.2, means it is greater than 0.05, and here also female it is greater than 0.05, it is also 0.2. Okay. So therefore data is normal. Okay. So then Levin test, so we are checking the mean based on mean. Okay. So data is also non-significant, means greater than 0.05. That means the data is fit for parametric test and independent test. Okay. Now what we will do, we will run the t-test. Okay. T-test how to do? It is we are comparing the two means, analyze, compare two means. Okay. Compare two means, after that there is one independent sample t-test that we talked about. So this is what we will do. What is the gender? We will take, this is a group variable, this is a string variable indeed. Okay. So then we can take it to this test variable, it is salary we are testing. So what we will do, we have defined gender as 1 and 2. Let us check here, we have written here, you can see. Okay. We have written male as 1 and female as 2. This is here values we have coded here. Okay. Unless we code, SPSS will not recognize this. So therefore it is essential we must code it. So this is 1 and 2. Okay. Indeed you can also write 3 and 4, there is no problem, or 0 and 1 you can write also. Okay. There is no issue. Okay. So this is okay. So now we have got, you can see, this is the t value. So this is, you can see what I was telling, male faculty are getting more salary 49,900 and female faculties are getting less salary, that is 39,400. Okay. So this is the standard error of mean. Okay. So now this is the t table which we must interpret. This is the t value 4.088. This is the degree of freedom. Degree of freedom means it is the sample minus 2. Okay. Number of sample we have used. What is that? It is the number of sample is 40. Okay. Let us check. So number of sample is 40. You can say. Number of sample we have got it. It is 40. You can say. This is 40 sample and there are two groups, male and female, minus 2. It is very simple. Okay. It is very simple. Therefore, we have got it as 38 here. Okay. So one must remember there are two things are here, equal variance assumed and equal variance not assumed. Okay. So here is also t value and significance value. There are two rows. Which rows we need to interpret? Let us remember. Let us understand this. Equal, if equal variance assumed, f, this is the f value 0.622 and this is non-significant. If it is non-significant, means it is the value is greater than 0.05, that means interpret the first row. Okay. So here it is non-significant. Okay. Here it is non-significant. Therefore, we have to interpret the first row. Okay. If it is less than 0.05, we have to interpret the second row. So this is the t value is 4.88, this is the degree of freedom, and difference of mean we have got it like 39,000, it's a 10,500 we have got. So this is the difference, these two difference we have got, mean difference 10,500 and this is standard error difference we have got it. And another thing you see, we can also see, if we found this lower and upper value, if we are found both are plus means it is, or minus, that means it is also significant. Okay. Okay. So it is, you will find here, this is the significant we are getting 0.0 means it is less than 0.05, that means value is significant, the difference is significant. That means there is a significant difference between the male salary, between the salary of male and female faculty members. Okay, that we have to. So what we can report that write in our reports, basically we can write like this: on an average, male faculty getting more salary. Within bracket we can write male average or mean m equal to 49,000 and standard error 1900. We have the standard error. Okay, so we have to also write, you can also mention that than the female faculty mean salary is 39,400. Okay, this difference is significant. Okay, and we have to mention it T within bracket 38. 38 means degree of freedom equal to 4 point, this is the what 4.088 and comma, and p value is less than 0.05. So we fail to accept H0. So this is what we can mention in our research report. Okay, this is how we can run the independent t-test in SPSS. That's for the lessons. I will see you in the next one. Thank you.